When I was doing my masters, I worked on Greek astrology, and when I was explaining to friends or people I met at parties what I worked on, the most common question I got, apart from what's your star sign, was hang on a minute, astronomy's the real one and astrology's the bullshit one, right? For most people in my social circle, astrology is bullshit. But that's not the case more widely, neither here in the West nor across the world in general. Not only do we have horoscopes in the majority of our newspapers here in the UK, but shift the terms a little bit and ask people if they believe in fate, and you'll get a very big range of answers. A lot of younger people in the UK and the US particularly believe in astrology and take it seriously. In some cultures, in many places in India, for example, astrology is important when it comes to picking auspicious days for doing things like getting married or holding a big event. And in some cases, people believe wholeheartedly in astrology, and in other cases, it's just one of those things you do, and you probably don't really care about whether it works. Much previous scholarship and a lot of pop culture thinking dismisses acceptance of astrology in the past as stupid, anti-rational, and anti-scientific. In the case of previous scholarship, some historians of science make kind of comically obvious attempts to cover up the superstition of the Greeks in a kind of embarrassed way. The underlying motivation of this lecture is to push a little bit at this issue, to look at why astrology and astronomy were logically linked in Greek thought, and what it would mean for thinking about ancient science if, as I'm going to argue, we should see astrology as scientific, as it appears within the Greco-Roman context. This is not particularly radical, and a lot of historians of science now take this view, but if, like me, you're a person who has grown up in an intellectual culture that is largely dismissive of astrology, it can take a little bit of time to get used to. Let's begin. So I'll start with astronomy. To begin, I'm going to summarise some of the astronomical elements that a Greek astronomer would have to fit into their astronomical model. And that is, remember in this period, of course, a geocentric model with very few exceptions. Many of these facets were not accounted for in the cosmological models we talked about last week, like Anaximander's model, but by the time of Plato, they do start to be accounted for in detail. So the first thing you might want to account for in an astronomical model is the fixed stars, just the stars you see in the background. So in a heliocentric model, we know that the apparent motion of the fixed stars, so the zodiac and all the other constellations, is because of the Earth's own daily rotation, and we're quite used to thinking about it that way. For the Greeks, who have a stationary geocentric model with the Earth at the centre, they think of that motion of the stars in the following form. So they think, well, the fixed stars have a uniform east-west daily motion across the sky, so that's around the celestial poles. So if you think about it as a big sphere with the stars, they turn round once a day. Okay, that's fine. So that's nice and easy. Mostly in the time of Plato onwards, the fixed stars are imagined like they're kind of studs or pinpricks on the inside of a huge globe. So that's probably the easiest way to imagine it, as a huge ball with the fixed stars on the inside. So as you rotate, the fixed stars rotate around in a 24-hour cycle. The sun, as you know, also has a daily uniform east to west motion across the sky. The path it traces relative to the fixed stars over the course of the year is called the ecliptic. In a heliocentric system, that means we think about the ecliptic as like the flat plane of the solar system. So if you picture the solar system, that kind of flat plane, the motion we make around the sun, that's the ecliptic. So that's at 23 degrees to the angle of the Earth. In a geocentric system, in which you don't have a tilted Earth, you have an Earth that's vertical, it means the ecliptic is at 23 degrees, and over the course of the year, the sun, moon, and planets are going round at that 23-degree angle. It's also worth noting that the Greeks were aware that the seasons were of slightly unequal lengths, as the sun moves faster in winter and slower in summer. It's again easy to think about why that happens in a heliocentric system, especially one that we have with elliptical orbit, where the seasons are just a bit of a different length because of that elliptical orbit. The Greeks are also, of course, aware that at different points on the Earth's surface, the sun seems to rise higher or lower in the sky. The other element we've got is the moon, which again has a daily motion around the celestial poles. It also has an eastward motion near the ecliptic over the course of the month, so it doesn't stay exactly on the ecliptic in the way that the sun does, and that gives you the lunar cycle. The moon and the sun in Greek astronomy have always been kind of relatively unproblematic to understand their motions and model those. But the complicated bit for Greek astronomy is the planets. So it's important to remind you, I'm sure you know this, but just to remind you that the Greeks only knew about Mercury, Venus, Mars, Jupiter, and Saturn. So Uranus wasn't discovered until 1930, and Pluto, who knows if that's a planet? It seems to go in and out of planet status. So the planets also have daily motions around the celestial poles. They also have, like the moon, an eastward motion near the ecliptic, but confusingly, it's at different speeds for each planet, which already seems a bit untidy, but can be resolved fairly quickly by saying, okay, they have maybe uneven orbit times. But here comes the big problem. The big problem is what's known as retrograde motion. And it's after this motion that the planets, the planetes or wanderers, are named. Retrograde motion means, in essence, that the planet, instead of moving on a neat east-west line near the ecliptic, instead has periods in the course of the year where it seems to stop and start moving backwards, turning back on itself towards the east, sometimes for as much as a few weeks, before turning around again and continuing their path westward. When you plot the motion of a planet across the sky over the course of the year, say I was to plot where Mars was at 8 p.m. every night for a whole year, the pattern I'll get looks something like this. So this problem of retrograde motion is really the astronomical problem that makes the whole thing complicated. What makes it worse is that different planets have retrograde motion at different times, for different lengths of time, different numbers of times through the year. So it's all quite individualised around the different planets. So if we consider this from our heliocentric point of view, we can see why this happens. So we're going around the sun, and as we turn, we pass by the planets at different times throughout the year because they're also orbiting. Usually as we turn, the planets go past us east-west, normally, as does the sun and moon. But when we're crossing over with a planet, the planet appears to go the other way for a bit. So that's what we're contending with. And I'll begin with Plato briefly before I move on to Eudoxus, who was Plato's pupil and a teacher in his own right at Plato's academy. Eudoxus most likely taught Aristotle. Plato's own astronomy is not very easy to reconstruct. We don't have a lot of details. We know that the basic elements included a series of concentric crystalline spheres kind of going outwards from the Earth. And remember last week that the idea of crystalline spheres I mentioned in relation to Anaximander, and that's probably became a norm after Anaximander. The sphere of the fixed stars at the outer edge of the universe had its inside studded with stars, as I mentioned before. That becomes the normal way of thinking about it. And that rotates around its central axis once a day. The sun, moon, and planets then moved on other spheres along the ecliptic. So Plato knew that the path of the ecliptic intersects the celestial equator. So if you imagine the equator on the Earth, if you imagine that projected out like a big disc around the Earth, like a big kind of skirt into space, well, the ecliptic intersects that celestial equator on what come to be known as the vernal and the autumnal equinoxes, which is what we still call them. And he mentions that. So interestingly, we know that there was some discussion in antiquity as well as to whether the Earth was tilted. I said before that in a geocentric model it's normal to think of the Earth as upright, but there was actually some discussion about whether the Earth was tilted and what that would mean. Most people, including Plato, we think, believe the Earth to be perfectly vertical and the stars to be tilted, or the movements of the planets to be tilted. Obviously, as I said before, when we envisage the solar system, we tend to envisage the solar system as a kind of flat plane with us tilted. Of course, our notions of absolute up and down only really make sense once you're in that heliocentric solar system, when you consider the plane of the solar system as horizontal. So anyway, we don't need to get into that. What we know from Plato's mathematization of physics, which I talked about last week with the constituent triangles of the elements and seeing it all as this kind of abstract mathematical underlying system, we know that his school did this similar thing with astronomy. It had the intention of finding combinations of geometrical processes in order to understand celestial motion. What's much more difficult to know is whether the particular innovation of combining different types of circular motions in order to explain retrograde motion of the planets, whether that was Plato's idea or that of his pupil Eudoxus. So I think Plato probably had an inclination that you could account for these retrograde motions using only circular motions, but Eudoxus was probably the one who worked it out mathematically, and in the next section I'll explain a bit more what Eudoxus did. The Eudoxian model has one key element that makes it work, which is the combining of two spheres in order to produce a motion called the hippopede, which is the basic element of retrograde motion. So the motion, the hippopede, the shape it is illustrated now on your screen. So the hippopede is produced by the rotation of two spheres offset at an angle to each other and turning in opposite directions. A point on the innermost sphere, if rotated like this, will trace out a hippopede. Here on your screen for the mathematically minded are the polar coordinates for the equation of a hippopede. So it took me a while to be able to visualise the hippopede. So I'm going to put in a quick GIF from Wikimedia where someone's animated it. So you should see that now. Let's just see that one more time. I hope this has given you some idea of what's going on, but if you still can't visualise it, it's worth looking it up on YouTube. So how do you get from the hippopede to the loop-the-loops from retrograde motion? Well, it's a case of adding in another circular motion which stretches it out. So now on your screen is what that looks like stretched out. Again, if you're mathematically minded, what's happened here in terms of the equation is that a left-right drift term has been added onto the hippopede equation from before, which stretches and unpacks the first half of the hippopede if you follow the sequence of points through time. Now, this is just an illustration. It doesn't represent any particular planet's motion, but you may notice that it does look quite similar to the loops characteristic of the motion of Mars that I showed before. Different patterns of retrograde motion can be produced by different orientations and different speeds of the spheres involved, but they're all made up basically of variations on the hippopede. This was a massive innovation, and to be honest, it still blows my mind every time I think about it, just how Eudoxus was able to visualise this and work it out. What's not clear is whether Eudoxus could ever actually fit this model to astronomical data, actual observed retrograde motions. It's likely the answer's no, that while he realised theoretically it would be possible to model actual planetary motions, the geometry involved in doing it, especially back engineering from the loop to the hippopede, then to the spheres and working out their speeds and offsets, would probably just be too hard for a human being to do. But who knows? So, okay, how does this fit together? Well, in theoretical terms, even if not in practical terms, what Eudoxus did was to accord a certain number of spheres to each of the sun, moon, and planets. And you remember earlier that Plato had this system of crystalline spheres, so this is what Eudoxus is doing. And conceiving of them as moving at slightly different speeds and different offsets to each other. So the fixed stars revolve on a big sphere around the outside in the same way as they did with Plato, and you're quite used to that by now. The Sun and the Moon, as I mentioned at the start, they have relatively simple motions. So in Eudoxus's system, they only need 3 spheres each. The outer sphere for each of them provides their daily rotation. That's fine. The middle sphere then offsets them to put them on the ecliptic for their yearly rotation. And then the inner sphere corrects for their latitudinal variation. They're fixed to the planet. I think he's thinking of it in this way, that the planets are fixed onto the inner sphere, with the outer spheres moving the inner sphere as it moves. It's kind of hard to visualize that, which again I think makes it very cool. But it's like the different motions kind of stacking up on top of each other. And he never talks about the physical, that we don't have any evidence of the kind of physical connections imagined here. So I think this is meant to be thought of as a mathematical and abstract model rather than necessarily a physically existent model. Okay, so that's the fixed stars, that's one. And then 3 spheres each for the Sun and Moon, so we've got 7 of these crystalline spheres so far. Now the 5 planets. So the 5 planets each have 4 spheres in the Eudoxan model, and I'm going to put a diagram up on your screen now. So the outer spheres, as with the Sun and Moon, are just the ones that rotate with the fixed stars and they provide the daily motion. Fine. The next sphere down, again like the Sun and Moon, for each planet is just what puts them on the ecliptic for their yearly rotation. Again, that's fine. Now, in the case of the Sun and Moon, you had just 1 sphere doing the latitudinal variation. Now with the planets, you have 2 inner spheres, and those are the ones that are the Hippopede spheres. So those are the ones which rotate against each other at the same speed in opposite directions to create the Hippopede. The interaction of these inner 2 spheres with the ecliptic sphere is what stretches out the Hippopedes in order to create retrograde motion. To account for the different periodicity of retrograde motion, i.e. when it happens, how long it happens for, the exact path it traces, all of those details, you've got to change either the relative angle of the Hippopede spheres against each other, so for a shallower or deeper Hippopede, or their speed relative to the ecliptic sphere to create more or less stretched out and different patterns of retrograde motion. The Hippopede spheres have to be rotating at the same speed as each other, because otherwise you won't get that figure. So you can see, if you had some incredibly complicated way of working out all of these parameters, you could nominally fit the Eudoxan system to the observed data, and I'm sure there's somewhere on the internet someone's probably done it. But you can also see how incredibly ingenious and crazy it is. I mean, yeah. So it was this system, the Eudoxan concentric sphere astronomical system, that became dominant in Greek thinking for some time. It was adopted and tweaked by Aristotle, who was probably Eudoxus's pupil. As I mentioned last week in discussing Aristotle's cosmology, Aristotle's a lot more interested than Plato in talking about the physical properties of elements and parts of the universe, rather than some underlying abstract mathematical structure. In general, Aristotle's much less interested in mathematics than Plato. So that means when it comes to astronomy, Aristotle took on a basically Eudoxan model with the concentric spheres and the Hippopedes and all of that, as far as we know, but he was more interested in what was actually physically happening, how elements including ether actually physically interacted and all the rest of it. So instead of taking Eudoxus's astronomy as this mathematical model, a kind of abstract version which explains how certain motions can be produced by geometrical combinations of circular movement, Aristotle takes it, as far as we know, as more of a physical model. And so he gets his biggest innovation is to deal with the problem of friction, which doesn't seem to be something that Eudoxus and the Platonists generally were that interested in. So for Aristotle, although all of the celestial spheres and all of the planets are made of ether, he still reckons that they are subject to friction. And I mentioned this last week with the friction of the celestial sphere moving past the sublunary sphere. But he thinks there's friction within the celestial sphere. So he adds this innovation, which they usually refer to as the unrolling spheres, which are these extra crystalline spheres in the system whose job it is to roll backwards against the motion of the rest of the system to counteract the friction. So Aristotle starts talking about having this huge number of extra spheres, way more than in the Eudoxan system. And the whole system actually under Aristotle gets kind of really unwieldy. And this sort of unwieldiness may indeed have been a factor in a switch that happens a century and a half later, where the Eudoxan model falls out of favour and the Ptolemaic or epicycle deferent model becomes the dominant model. The Ptolemaic astronomical model is more properly called the epicycle deferent model. I'll get to what those terms mean in a minute, because we know it was introduced quite a long time before Ptolemy, who wasn't until the 2nd century AD. It's just that Ptolemy's version is the most famous one. So the epicycle deferent model was introduced probably by Apollonius and Hipparchus at the end of the 3rd century BC as a way of getting away from some of the worst difficulties of the Eudoxan model. As we saw, one of the things that was incredibly hard to calculate in the Eudoxan model was the actual angle of the Hippopede spheres, and their exact speed and motion against the ecliptic sphere for each planet. That's to say, while the Eudoxan model shows very clearly how, in abstract terms, one could get retrograde motion from the combination of spheres moving against each other at different angles, those different angles and the different speeds involved in the spheres are incredibly difficult to fit to the observational data. The epicycle deferent model, on the other hand, is extraordinarily flexible. In fact, any path at all, however complex, can be represented with a finite number of epicycles, although obviously the more parameters you add for any model like this, the more difficult your model becomes to work with. There's a thread of history of science that argues that Copernicus's heliocentrism was actually an attempt to mathematically simplify the Ptolemaic epicyclic astronomy of his day, which had added more and more of these epicycles, and as I say, I'll get back to what that means, to refine the system. So how does this actually work? I keep saying these words, epicycle and deferent. So the subtlest and most sophisticated of the epicycle deferent models was developed by Claudius Ptolemy in the 2nd century AD, and that's the one I'm going to summarise. So I'll put a diagram up on your screen now. So in this diagram, the larger cycle is what's called the deferent, and the smaller cycle is what's called the epicycle. So what happens is the planet is fixed to the epicycle, the planet moves around the epicycle, and as it moves around the epicycle, it's also moving along the deferent, and the combination of the two circular motions is what produces retrograde motion. In order to account for the right number and speed of the retrograde motions, the epicycle would have to move at different speeds at different times, and this turned out to be a bit of a problem. Ptolemy didn't really like this. So although the basic conception of, hey, here's a simpler way than Eudoxus, that you can combine two spheres to get motion, to get the retrograde motion, in the epicycle deferent model, the motions aren't a consistent speed, or they wouldn't be unless you did something else to it. An uniform circular motion had been at the bottom of all Greek astronomical systems since Plato or even before. So what does Ptolemy do? Well, he hits on the idea of decoupling the physical centre of the system from the centre of the motion of the system. You'll see in your diagram that instead of having the Earth at the centre of the deferent, it's a bit offset. Instead, there's a cross marked as the eccentric. So that's the physical centre of the system, the centre of the deferent. The other point, marked as the equant, is opposite the Earth, equidistant from the eccentric. It's this point that is the centre of the motion of the epicycle. It may be a little hard to visualise, but the idea is that by having an offset like this, the motion of the epicycle can still be at a constant speed, so that avoids that problem of previously having circular motion at the basis of everything. People were generally not keen on this solution. It was felt to be messy, but it was a way for Ptolemy to preserve uniform circular motion. This system, once Ptolemy had worked it out, was one of the most adaptable systems of Greek astronomy, and it's the one that lasted, well, really until Copernicus and Kepler. What's less remarked upon is Ptolemy's other interest, which is in astrology. And in what remains of our time, instead of going further into the epicycle deferent model, I'd like to talk a bit about astrology and try and convince you a bit of how we should see astrology as a science of antiquity, just as we see astronomy as one. Astrology is a complex subject. In many ways, it's every bit as complicated as astronomy. It's only really in the Hellenistic period that astrology became a big kind of worked out technical system. Although it's tempting to think of astrology as stretching back into the mists of time. In fact, a lot of what the classical Greeks inherited was more like what we'd think of star lore. Lots of big omen catalogues like the Babylonian catalogue Via Numeranu Enlil, which includes stuff about the weathers and star risings, but puts that alongside omens, predictions about the royal household, that sort of thing. Much early astrology does not distinguish between different types of prediction in this way, and it's also not particularly interested in predictions made about individuals, otherwise known as natal horoscopy, which is the format we know and think of as the casting of a horoscope. By the Hellenistic period, in Greece, astrology had become much more complex, and it had taken on several different systems and traditions, including material from Mesopotamia and Egypt primarily. Egyptian astrology had its own whole extra system, but it possibly also had some influence from India, and ancient Indian astrology was also very technically complex. For those dipping into Greek Hellenistic astrology for the first time, it's confusing for a number of reasons. One main reason, once you get past some of the initial shock and impenetrability of just how much jargon there is in writing about astrology, is that there seem to be kind of two different systems at play, and it's not always clear how these interact. One system is to do with the zodiac, the 360-degree 12-section star map of the night sky, which schematically splits the sky into 12 constellations, 12 equal-sized arcs of a circle constellations, and then looks at the position of the planets as they move across the zodiac. This system, the kind of zodiacal planetary system, involves words like conjunction, aspect, ascendant. This system is primarily concerned with tracking where the planets are against the zodiac, which sign a planet is in, and then after that tracking the relationships of the planets to one another. Planets are said to be in aspect to one another, literally conceived of as looking at one another as they go round. The range of aspects begins with something more intuitive, like conjunction, where that means two planets are in the same sign in the night sky as they move. Opposition, where two planets are directly opposite each other, kind of on the wheel of the zodiac. So if you imagine, say for example, you have Jupiter directly above the North Pole and Saturn directly above the South Pole, you would say that those two planets were in opposition to each other. The other aspects involve a little more geometrical imagination. So having conceived of opposite points on the kind of 360 of the zodiac, it's not too far a step to start thinking in smaller fractions. What about points that are a quarter of the way around the wheel, planets a quarter of the way around the wheel from each other? Well, that relationship is known as square. Planets that are a third of the way around the wheel from each other, so a slice of 120 degrees from each other, that's called trine. Planets that are only 60 degrees from each other are said to be in sextile, and all of these relationships are said to have their own rules about whether they're positive or negative and what they mean. So using this planetary system, astrologers can build up a large database of information. So having taken an initial snapshot of the night sky and written down where all the planets are at a particular moment, say for example the moment of someone's birth, you look at what sign each of the planets is in, so you catalogue the location of each of the planets, and then you can catalogue the aspect of each planet to each other planet. So that more than doubles already the pieces of information that you have at your disposal to start making predictions and interpretations. But then, so that seems to make sense as a system. But then you've got this sort of second system that's lying alongside, and that's the system of houses. And that works something like this. So as well as being divided into 12 equal-sized zodiac signs, the 360 sweep of the heavens is also divided into 12 numbered houses, they're called. Different traditions define the relationship between the houses and the zodiac differently. But in Hellenistic Greek astrology, the houses map onto the zodiac signs in the following way. So whatever sign is coming over the eastern horizon at the time of birth, and that's in fact where we get the word horoscope for, that's called the horoskopos, whatever's coming over the eastern horizon, that sign in the house system is designated as the first house. So you can work out that by symmetry, the sign going down over the western horizon is the sixth house. Now, once you can catalogue all of these details, and there's a lot more to the house system. There's houses each have their special importances. It's important to know what the midheaven point is, the highest point, and then what's known as the imum caeli, the kind of the opposite to the midheaven. And these all have their influences. So that's like another system alongside the planetary zodiac system. So now once you can catalogue all of these details, how do you start calculating and interpreting the effects of all of these things? Well, let's take the planets first. So the planets all are meant to have their own characteristics. For example, Saturn is almost universally thought of as sad and serious. Mars is thought of as angry and violent. Mercury is thought of as changeable and fickle. These characteristics do change a little bit between different astrologers. For example, in the astrologer Vettius Valens, he writes a great deal about the characteristics of the planets. They have quite a wide range of characteristics. In Ptolemy, who takes a kind of more Aristotelian approach to these things, Ptolemy starts assigning the same qualities as are assigned to the Aristotelian elements, like hot and cold, wet and dry, and he creates this system with the planets where they're all kind of like Aristotle does with the pairs of elements, where there's this kind of complicated balance where some things are hot and wet, some things are cold and dry, some things are this, that, and the other. The planets are also thought of as some planets are male, some planets are female, so that's another kind of duality that's introduced into the system. But in general, the base characteristics of the planets remain constant. The planets are thought to have different influences depending on which sign of the zodiac they're in, and the zodiac signs are also thought to have their own characteristics. So then too, after you've got that, the combinations of planets and zodiac signs, you add the combinations of the aspects of the planets to one another. So some planets are thought to go well together, like Jupiter and the Sun, who are basically both good, cheerful planets. And some planets are thought to go badly together, like Mars and Saturn, who are kind of bad, disruptive planets, or Mars and Venus, who tend to fight each other because they're seen as opposites. So again, these are all kind of inherited traditions about these sets of characteristics. And so an ancient astrologer would either learn all of these, or there were manuals that you could look these things up in when you're doing a horoscope. So you've got all of those different moving pieces, and now you've got the house system as well. So the houses are traditionally assigned different areas of the life. So for example, the fifth house, its nickname, it was known as the house of good fortune, and that tended to be associated with information about your children. So if you were having a horoscope done and the astrologer was looking at what was in the fifth house, and if your horoscope happened to have Venus in the fifth house, Venus is associated with fertility and childbearing, then having Venus in the fifth house is probably a very good sign. It might indicate that you'd have many children, or your children will be healthy, or something like that. And the precise details would be up to the astrologer. And so on for the various houses, which all have their own names and particular areas of influence. So you can see just from this short overview how you can build up an enormously detailed picture from the pieces of information available, and how this is a very complex combinatorial system which mixes traditional interpretations with the astrologer's own on-the-fly interpretations. The question of whether astrology is scientific, I think, is in some ways related to the question of how scientific astronomy is. I think there's a case to be made that Eudoxus was particularly important for the development not only of astronomy but of astrology for the following reason. The Eudoxian model gives us a systematic mathematical model to attach the zodiac to. It constituted the sort of scientization, the mathematization of astronomy. It becomes something concrete and mathematical. And I don't think it's a coincidence that in the couple of centuries following Eudoxus, we start to get the first Greek horoscopes from papyri and inscriptions, written up and very systematic. Astrology moves in this period, in Greece at least, from being quite an amorphous collection of ancient wisdom and lore to a precise, practicable science in which the effects of any number of astronomical combinations could be worked out, charted, documented, and most importantly, formed a set of basically predictable predictions. As I said in the previous section, although there's some interpretive space for the astrologer, there are some fairly set, predictable characteristics. So anyone with the correct tables and knowledge could, if they made the right calculations, come to a pretty similar prediction to somebody else doing the same thing. The epistemic status of astrology underwent a huge shift. So its authority was no longer revelatory, but explicable, the logical extension of mathematical astronomy. It was, of course, still in many ways a deeply religious activity. We only need to remember the reverence with which someone like Plato treats the heavens in the Timaeus, when I was talking about his cosmological account. There's a lot of this astrological stuff, there's a lot of stuff about the fates. But nevertheless, it becomes a system that has a sort of basically rationalist underpinning to it. Ptolemy's Tetrabiblos, which is the companion work to his Almagest, which is his great astronomical work, the Tetrabiblos is his treatise on astrology. And I'm going to talk a little bit about what's in it, because it will give you a bit of a picture of how astrology relates to astronomy. So the first book of the Tetrabiblos consists of a defence of astrology. It explains astrology's relationship to astronomy, and it sets out what you can and what astrology can and can't tell us about the world. Then it summarises the theoretical setup of the astrological system, which I've talked a little bit about in more general terms in what I just said. The remaining books of the Tetrabiblos treat astrology in greater and more specific detail. So Book 2 focuses on what's known as general astrology, which is the study of predictions which concern whole races, whole nationalities, countries, cities, so on. Books 3 and 4 focus on genethliological, which is just another word for horoscopic astrology, i.e. the casting of individual horoscopes for people at their time of birth, or based on their time of birth. Both in ancient times and in modern scholarship, these two types of astrology are conceptualised as distinct. There were many ancient philosophers who considered various types of predictions that fall under the remit of general astrology to be legitimate and knowable, like, say, weather prediction or trying to predict some things about major political events, but who some of these philosophers rejected horoscopy, and natal horoscopy was, even in its own time, a controversial subject. The Tetrabiblos makes two major categorical divisions early on. The first of them appears right at the start in Tetrabiblos 1.1, where Ptolemy declares that there's two types of prediction as regards the stars. First, he says there's the prediction of the stars' movements, and second, there's the prediction of their effects on the Earth. The first type he's dealt with already in the Almagest, and that's astronomy. The Tetrabiblos is the treatment of the second type, that is, astrology. Now, it's a bit of a truism among historians and historians of science of a certain period to say, well, there was no real distinction in antiquity between astronomy and astrology. This isn't strictly true. I mean, obviously it's slightly silly. As you've just seen, astronomy is very narrowly concerned in the Greek period with accounting for the movements, both theoretically and observationally, the movements of the stars. Often, as in Eudoxus's model, they're not even interested in the physical, how it physically works, let alone how it affected people on Earth. On those grounds, yes, of course there was a distinction. But there wasn't anywhere near the distinction that we see today, because the backdrop, the kind of cosmological backdrop, as we've seen in previous weeks, the way the Greeks saw the relationship between the heavens and the Earth, didn't make such a strong distinction meaningful. And you'll remember from my discussion last week of, for example, the Stoics, the idea that the heavens are made of the same stuff as human souls. These kind of things make it quite easy to think, of course it follows from calculating the movements of the heavens that you can calculate their effect on Earth. As Ptolemy goes on to point out, astrology is the less precise of the two sciences because it deals with objects and events in the sublunary sphere, which, as you remember from Aristotle, is made up of the four elements rather than the eternal ether, and therefore it's the sublunary sphere subject to change and the influence of unexpected causes. Astronomy, on the other hand, as it deals with the celestial sphere, can deal in certainties. Ether's perfect, it's fixed, it's unchanging, and therefore it can be modelled mathematically. Ptolemy goes on to lay down some important epistemic boundaries for astrology. He notes that its detractors are correct to point out that astrological predictions sometimes fail, and he posits several possible causes for this. And a couple of the main ones, he says, are, okay, well, predictions are often made improperly by unskilled practitioners. And second, another thing he says is, even if predictions are made correctly, qualitative rather than quantitative science, like astrology, is inherently conjectural, and it's not to be absolutely affirmed. The first point, that people sometimes just make bad predictions, is important. Ptolemy doesn't make any assertion as to whether it's practically possible to carry out perfect astrology with perfect accuracy, or whether it's only theoretically possible, but that every actual person attempting it will be necessarily flawed by, for example, not having good enough instruments or making human errors. It's easy for us in a kind of post-Enlightenment world to make a distinction between something being necessarily always impossible and something being just technically we can't really do it technically. And it's easy to forget that such a distinction is maybe a bit less clear in the ancient world. The second point about qualitative science rather than quantitative science shows that Ptolemy is quite aware that as a less precise science than astronomy, astrology can only make a weaker epistemic claim. That's to say, the knowledge derived from astronomy, the mathematical knowledge of the planets, is really true and certain. The models are, in Platonic terms, dealing with dianoia. As you'll remember from the second lecture, we talked about these different levels of knowledge, and dianoia for the Platonists was just down from the knowledge of the forms. And so, this is quite a high bar for knowledge. It's of the celestial sphere, which is immutable and eternal. But astrological predictions are not about that. They're about the sublunary world. They're never claimed to be true and certain knowledge. They're guides. And Ptolemy illustrates this image by using a metaphor from what's known as iatro mathematics, or medical astrology. So his metaphor is this. So how about, say, you have a doctor who goes to see a patient. The patient has a sore on his leg, and the doctor says that sore will go gangrenous, it will cause putrefaction. Then the doctor leaves. Then the patient applies some kind of poultice to the sore, and the sore heals. It doesn't cause putrefaction. In this case, we wouldn't say that the physician was making a false prediction. He was merely working with the available information he had, but some other cause intervened. The patient did something else. Although we must be a little careful, this is sort of probabilistic. There's no real theory of probability in ancient maths, but you can see that there's a similar reasoning to it. So, when you have condition X, says the physician, then Y tends to happen. If steps are taken to prevent Y happening, it doesn't mean that the physician's claim was any less true, nor does it make Y any less likely to happen the next time someone has physical condition X. So we would say the doctor's prediction is sound, given no outside influence. Ptolemy's view of astral determinism is very similar to this. And I quote, "We should not believe that separate events attend mankind as the result of the heavenly cause, as if they'd been originally ordained for each person by some irrevocable divine command and destined to take place by necessity without the possibility of any other cause whatsoever interfering." We've seen Ptolemy acknowledge earlier that the sublunary sphere is a complex place where a number of different causes can interact to bring about events. Here he makes his claim more explicit. In theory, by taking horoscopes and determining the characteristics of human beings, astrology can give us a clear picture of what will happen to that person who we've done a horoscope for, provided other causes don't interfere. Let's apply Ptolemy's reasoning and take an example. So, say a baby boy is born under Mars ascendant. The inherited law says that being born under Mars means that he'll be hot-headed and he'll be bellicose and angry. On the basis of his birth time, we can say that this hot-headed boy will, in the course of his life, have stormy affairs of the heart and make a number of enemies. If he goes into the military, he'll be a good fighter, but he'll probably die in combat. To the modern eye, this looks a lot like psychological profiling. We might want to call this person an extrovert or an alpha male. The only obvious problem with this analysis is that it's treated as axiomatic that a person's birth time is related to their characteristics. All the rest of it is kind of acceptable to us, I think. We need to be careful, so the hard logic of whether the stars cause characteristics or merely align with and signal them is actually a major flashpoint for critics of astrology and a major topic in the history of philosophy. But even leaving this aside, Ptolemy's careful and methodical in his explanation of the Aristotelian physics of the planet's characteristics. The whole system is explained in terms of the hot and cold, wet and dry distinction, which I mentioned earlier. As these come from Aristotle's cosmology, the primary axes along which the four elements interact and mingle. So in short, Ptolemy's conception of astrology is entirely logical and rational within a Stoic Aristotelian worldview. If you believe that the four elements mix in such a way that everything's ordered symmetrically along the axes of hot, cold, wet, dry, that phenomena, materials, planets and so on have discernible equal and opposite reactions with one another, sometimes in complex and second-hand ways, but always with an underlying logic. If you believe also in the principle of cosmic sympatheia, that is, that the universe is interconnected and what happens in the heavens can have an effect on what happens on the earth and vice versa, and you do believe this in a physical sense if you're an Aristotelian as well as a Stoic, because the Aristotelians did believe that the movement of the heavens did directly affect stuff on the earth. So within that worldview, astrology is perfectly sensible, and a perfectly sensible extension of the science, as we've been talking about it, of astronomy.